What is up, everybody? Welcome to 5.1 Euler's number. So, what is Euler's number? Euler's number is Euler was a mathematician. He was really good. He came up with the no. He came up with the Euler's formula, which was to determine how many like the sides, the edges, the faces, and the vertices, however many, what the relationship between them was, and he came up with a lot of that stuff. So he's a really profound mathematician in the 1700s, and he made his own number. So he was interested in banking. Uh, I I think it was his teacher and him was interested in banking as well, and he asked the question on how much money would you get if something was compounded continuously given a rate of 100% interest. So for example, if your money is compounded yearly and you get 100% interest every year, you'll have $1 first year, and then you have $2 the second year, and then the next year you have $4. If it's compounded biannually, if it compounds 2 times every year, then you'll get 50% increase in the first half of the year. So $1 will turn into 150, and you'll get another 50%. So 150 will turn into 225, because half of 150 is 75, which is 225. So as you go up, so for example, once you get to the monthly, you'll get 261, and then once you get to the daily, you'll get 260 something, and then as you go up, the number, as the amount of times you compound, get larger and larger. If you do it every second, you'll probably get about 2.7, and then if you do it every instant, every moment, you will get 2.718281828459045. Yeah, that's all I remember. But you will get a number called E, and E is a really useful number in all of mathematics, and you will understand why when you get into calculus, differential equations, topology, maybe not that far, but calculus and many other different fields relating to calculus and integrating with non-elementary equations. A lot of functions will use E, Taylor series as well. So E is I'm gonna show this to you, notation, not to scare you or anything, but I'm trying to prepare you for the upper levels of math, for example, calculus. So what is this notation? It's limit as x approaches to infinity of 1 plus 1 over x to the x power. So limit as x approaches infinity means as x approaches infinity, not when x is infinity. As x approaches it, as it gets to infinity, the result will be this 2.71828, right? And if you can see, as x approaches to infinity down here, you will get 1 over x approaches to infinity. You'll get about you'll get a number really close to 0, and then as x approaches to infinity, you'll get a number that's approaching infinity as really large, infinitely large, but it's not infinity. So once you get those numbers, it's basically 1 plus number really close to 0 to the power of an infinitely large number will give you 2.71828. That's, you normally only use the first 3 numbers like pi. So 3.14, you'll use 2.72 in this case. And this is the graph of y e to the x. It's just normal, right? And then a natural base exponential equation. A natural base exponential equation, E is considered natural, right? E is natural. A natural base exponential equation is defined as y equals ae to the b x, where a and b are constants and e is the natural base. is considered as the natural base. So it can be any constant, but it has to be there has to be e and x, e to the x on top to be a natural base exponential equation. So for example, y equals 2e to the negative x. That works, right? Because it is an exponential equation and it is a it has a natural base in it. So e to the negative x is actually 1 over e to the x, right? And then 2, so you have 2 over e to the x, which gives you this exponential decay, because as x gets bigger, function gets smaller, and the asymptote, we've talked about those horizontal asymptotes, is at 0. So what about y equals negative e to the x? Now notice I didn't put negative e to the x, because that will, I did not put this because this will cause a lot of confusion, and the function will be up and down many times. So you don't normally do that. Instead, you do this. You'll do negative e to the x, which will give you exponential growth, however, in a negative direction. So, for example, if you owe someone debt, and then they charge interest on you, you'll get exponential growth in the negative direction, which you definitely don't want. Let me just tell you that right now. Okay, so exponential growth or decay. Determine whether each function has an exponential growth or decay. First of all, 2e to the x. As x becomes higher, will this number become higher? Let's see. Okay, we put 1 in there, you'll get 2e. 2e is roughly 5.6, right? 2e is rough. I'm just gonna use 5.4. I'm just gonna use 2.7 as the e, right? And then if you put 2 in there, you'll get 2e squared. So 2e squared is roughly equal to 16 or 15.5. So it's getting bigger. So it's exponential growth. Exponential growth. Right, next. G to the x equals negative 3e to negative 2x. Just by modifying this, you should already know what it is, but let's see. Negative 3, and then e to negative 2x is also e. It's also 1 over e to the 2x, right? And then that's equal to negative 3 over e to the 2x. And if you give me 1, you'll get negative 3 over e squared, which is roughly negative 0.3. And then if you give me 2, it'll be negative 3 over e to the 4, which is about 0.1. So negative 0.1. So it gets smaller and smaller. So it's exponential decay. Okay, next. X times 3e to the 2x. Is this exponential growth or an exponential decay? It's actually not an exponential function, because there's an x in front right here. There's an x right here, and if there's an x, it's kind of a compound function rather than an exponential function. But let's treat it as if it was an exponential function. Is this exponential growth or decay? We'll add 1 in. 1 times 3e to the squared, and 1 times 3e squared is roughly 24. And then 2 times 3e to the 4th power. E to the 4th power this is about 300. So yeah, definitely exponential growth. Next, 300e 0.5x. So e to the 0.5x is also known as square root of e, but we're not going to talk about that yet, because we are going to figure out if this is exponential growth or decay. So we can put 1 in there. 300 square root of e is roughly about 180, right? 300e is roughly about 810. So there's a big increase, so it's exponential growth. So what can you conclude from this? You can conclude that exponential growth functions are actually have a positive positive uh, exponent. So if the x is positive, it's an exponential growth. 2x exponential growth. 0.5x exponential growth. Negative 2x, it's negative, so it doesn't have exponential growth, right? Next, continuously compounding interest, right? So this is to show, if you don't understand this, you don't have to. I will explain it more maybe in a later math video, but you guys have learned this hopefully in Algebra 1, hopefully in Integrated Math 1. Principal times 1 plus rate over n is the number of times compounded per year, over to the power of nt. So since the limit as n approaches infinity of 1 plus 1 over n, the n power gives e to the first gives like e to the first power. Then the limit of n as n approaches infinity of 1 plus r over n to the n power gives e to the r power, right? Because this r is your rate. So as there's a different asymptote whenever you have the rate as the top, or whenever you have the rate on the top, be a different number than 1. So the formula for continuously compounding interest is PECRT, where P is the initial investment or the principal, R is the rate, and T is the time. So 3% interest compounded continuously for 40 years with an initial investment of 2,500 is 2,500, right? That's P, and then E, and then R is 3% interest, 0.03, and then T is 40. So 2,500 e to the 0.03, 40, which is about 2,500 e to the 1.2, which is about let me put it on the calculator. 8,329. $8,329. No, $8,300.29. Right? Okay, there you go. So let's do some practice problems. How do you see it? Use the graph to complete each statement. F of x approaches what as x approaches positive infinity? Okay, as x approaches positive infinity, so on the right side, as x approaches positive infinity, f of x looks like it approaches positive infinity as well, right? As f of x approaches negative infinity, as x approaches negative infinity, looks like this is a horizontal asymptote line. So I've already told you what an asymptote is. It's where a line normally approaches, it gets really close to it, but it never actually reaches it. So it's 0. It's not negative infinity. I'm sorry, 0. Next, problem solving. The growth of mycobacterium tuberculosis bacteria can be modeled by the function n of t equals ae to 0.166t, where n is the number of cells after t hours, a is the number of cells where t equals 0. At 1 p.m. there are 30 m tuberculosis, 30 million, 30 m tuberculosis bacteria in a sample. Write a function that gives the number of bacteria after 1 p.m. I'm assuming that's 30 million, right? So 30 million is 30 million e to 0.166 t, right? Use a graphing calculator. No, we're not doing that. Describe how to find the number of cell samples in the sample at 3:45 a.m. So at 3:45 p.m. So in order to find the cell sample at 3:45 p.m., t is the number of hours after after the cells are t is the number of hours after the cells are in the sample. So the number of hours after the cells are in the sample is 1 p.m. to 3:45 p.m., which is 2 hours and 45 minutes. And 45 minutes is 3/4 of an hour, so it's 2.75 hours, 75 hours. And if I put that in this function, you will get 30 million e to the 0.166 times 2.75, and that will give you, so 30 million times e to the power of how much? E to the power of 0.166 to multiplied by 2.75. Let me do 0.166 multiplied by 2.75. You will get that. Okay, 0.4565. So 30 million multiplied by e to the power of answer will give you 47,356,182. 47,356,182. 47,356,182. And that is the answer. Final question. Drawn conclusion. You invest $2,500 in an account saved for college. Account 1 saved 6% annual interest compounded quarterly. Account 2 saves 4% annual interest compounded continuously. Which account should you obtain to obtain greater amount in 10 years? So, using our two formulas, I'll write them down right now. P1 plus R over N to the NT, and PERT should give us the answer. So first of all, account 1 is pay 6% annual interest compounded quarterly. Quarterly means 4 times a year. 4 times a year. So P is 2,500. That's fixed, right? 2,500 multiply by 1 plus R is 0.06 over 4 to the 4 times 10, since it's 10 years, right? And then the second one is PE to the 0.04 and then times 10. PE to the RT. So let's see which one's better. Okay, so we're gonna work out this first one first. 2,500 times what? 1.015 to the power of 40 will give you 4,535.05. 4535.05, right? And then PE to the 40th will give you times e to the 0.4 . This, on the other hand, will only give you 3,729.56 . So this is overall, the top function is overall the better function in the long run. So that's it for today's lesson. Come back next time for logarithms. Bye. See you next